Welcome to Molecular Composition of Gases and Gas Reaction Stoichiometry. We're going to be using a lot of the principles that we have learned before. Many of the things that you see in this video and in our studies are going to be things that we have studied before, because the study of gases led to the formation of many of the laws and principles that we have used in the past. Things should look really, really familiar. We'll just be using volumes instead of masses. Gay-Lussac's law of combining volumes of gases. The law states that at constant temperature and pressure, the volumes of gaseous reactants and products can be expressed as ratios of small whole numbers, much in the way that in previous stoichiometry problems and in previous reactions we used the coefficients to express moles. In this case, they can be used to express volumes. So what that means is that if I have 3 liters of helium and 3 liters of oxygen, if they're at the same temperature and pressure, they will have the exact same number of molecules and therefore the same number of moles. Avogadro's law. Equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. As the previous example I gave you in the last slide, if we have the same volume of 2 different gases at the same temperature and pressure, they will have the same number of molecules. One of the things we're going to be using is standard molar volume of a gas. 1 mole of a gas is 22.4 liters at STP. STP is standard temperature and pressure. That's 0 degrees Celsius and 1 atmosphere. Okay, so now let's work a problem. A chemical reaction produces 0.0680 moles of oxygen gas. What volume in liters is occupied by this gas at STP? We're going to be using dimensional analysis. Keep in mind that's going to be the given times the conversion factor. We'll put our given 0.0680 moles over 1. We'll multiply it by our conversion factor. In this case, it'll be 22.4 liters over 1 mole. Notice the moles will cancel out. We carry out the math, and the answer will be 1.52 liters of oxygen. Now you need to pause this video and try to solve these 2 problems. Here are the answers for the problems. Well, for the first one, you should have gotten 159 liters of nitrogen gas. And for the second one, 1.63 moles of chlorine. Here's another type of problem. Notice I'm going to start you off with grams first, which means you have to change the grams to moles, and then use your conversion factor for STP. The first thing we're going to do is change the grams to moles. So 180 grams over 1 mole of water has a mass of 18 grams. Then we'll multiply it by the 22.4 liters over 1 mole, and that'll give us the correct answer. Okay, now go to Google Classroom, pull up the worksheet molar gas volume, and try those problems.